In our last video, we built a fairly simple slime enemy, but how are we going to be able to build advanced enemies with a brain? In today's video, we're going to build the system that makes this possible. Hi, my name is Michael. Join me as we build an epic Metroidvania game in Godot 4 using GD script. This is the Metroidvania Forge. All right, maybe you've wondered in the past how you can go from a simple hard-coded enemy to a system that's more robust and allows you to plug and play and reuse pieces and things like that. Well, today we're going to do just that. We're going to be diving into the deep end of building a state machine driven enemy with a decision engine. So it's kind of like you could think of it as behavior tree light. Okay, where we're going to be able to drop in a script that makes decisions. And this will all integrate into things like sensors and whatnot on our enemy. We built a slime that was kind of all hard-coded into the enemy slime script that we made in our previous video. And this time we're going to kind of break that out. We're going to make another slime, but this time we're going to build him using some different set of systems. So here I've represented kind of the outline or the goal of the various nodes that we're going to create. So each enemy is going to be a scene in and of itself. Okay, and they're all going to share an enemy script that has all the basic things that an enemy needs to make him work. Okay, and so we'll have a few variables there that we can configure and change on the enemy. And then what we're going to be building, and you can see I've got a Blackboard, a state machine, decision engine, and sensors and modular nodes. Okay, let's start with the sensors and modular nodes. These are pretty straightforward. We've already built a few of those, like the hazard area and the damage area. We're going to be adding a few like an edge detector, as well as player sensors and some other things that we can drop in, okay, like maybe enemy particle node that will help spawn particles and things like that. Then we're going to have a finite state machine. So much like our player who has a state machine, we're going to build one here for our enemy. It's going to be a little bit abstracted from the enemy script. It's going to live on its own. So we'll have a state machine script and we'll have enemy states that will be interchangeable. And then we'll also have a decision engine. Now, the role of the decision engine is to take information from the sensors, from the enemy, and help decide which state to change to on the state machine. So the state machine and the states aren't usually going to be making any decisions. That will be handled exclusively, hopefully, by the decision engine. And lastly, this Blackboard. This Blackboard is just an extra piece that holds data so that everything can kind of live independently from each other. And it's hopefully going to help us keep our code a little bit cleaner. And so the Blackboard's going to contain things like our enemy's hit points, the target, if he has a target, the distance to the target, is there an edge that we're detecting, and things along those lines. Okay, so this is the system we're building. Whatever I build for the base enemy script is probably not going to be final. All of the sensors and nodes will be self-contained and work perfectly for their need. You may find the need to add new ones of your own as you go through the series or beyond. The finite state machine 2 will be pretty fixed. The decision engine is a little bit different. So this is the piece that is probably going to be different per enemy. And so there is going to be custom scripting per enemy. I think this is a good way to handle it though, because then we limit our scripting to just the conditional logic in the decision engine, right? And so that's going to do things like check, okay, do I have a target? If yes, then I should be in the chase state. If no, then maybe you're checking other things like, okay, am I on the edge, or am I on the ground, or is my timer up? And if so, then what will I do in those cases? Will I walk? Will I idle? And so on. And so obviously you're going to write different styles of decision engines, but they'll all kind of extend from this engine and plug into this system. And then you can kind of mix and match as you need to. All right. So that's an overview of what we're going to be building. I don't know if this little diagram helps or makes it more confusing, but we're going to just dive into the deep end and recreate our slime using this new system. And by the time we're done, we'll have the basic building blocks that we need to start building more advanced enemies. Okay, so let's start setting this up. Now, one thing that you're going to need to do is, especially if you've been following along, as of the recording of this video, I've updated the chapter 5 zip file. So what am I on? I'm like April 6th that I'm updating this, which by the way, today is the deadline for the enemy showcase, the day I'm recording that is. So when you're watching this, deadline is passed, but that means I'm very close to having that enemy design showcase video, which is going to be fun because we're going to pull in a lot of those enemies into this project using these systems and build them. Okay. But I've just added a couple things like this enemy hit particle icon, and let's see, a player sensor icon, and what else? An edge sensor icon somewhere, I think. Yeah, there it is. Okay. So those aren't really even critical, but go ahead and grab those if you want them. But let's go ahead. I'm going to come up to my, I've got an enemies folder. Yeah. And we've got scripts in here. We've got a slime. And in here, we're going to start adding some additional things, right? Now, first off, I want to go ahead and add let's add a new folder. That's what I want to add. A new folder. So create new folder. And for now, I'm just going to call this, maybe I'll just call it slime 2. I don't know. Obviously, slime and slime 2, somewhat experimental to some degree. But in here in slime 2, I'm going to create a new scene. I'll call it slime 2. I'm not really a huge fan of that, but whatever. And I'm going to go ahead and change this type to be a character body 2D. I'm just going through the basic steps that we went through to set up our other slime enemy, right? In addition, we're going to need a new script. So let's go into our enemies folder. We've got an edge detector script in here that we've already built. And I'm going to create a new enemy script. Create new script. Okay, this script should be called enemy. And it should extend or inherit to character body 2D. And I'm going to go ahead and create that. Okay, holy cow. Too much, sorry. I'm going to delete it. Okay, so let's give this a class name. Now, this is our enemy. I want it to be a tool script because we're going to be adding custom configuration warnings to this. So I'm going to go ahead and make it a tool. And let's add the icon for our enemies. Boink. There we go. Got an enemy script. Okay, so all of our enemies are going to use this script on their route. So I can come to my slime, actually, and we can attach this script here. You know, this is a different way. I don't normally do this. Let's find our enemy. Okay, so now our slime is an enemy script, and let's go ahead and kind of set up some of the slime visually so that we have something to start working with. So of course our slime needs a sprite 2D. And let's see, let's go ahead and add our slime sprite here. Very good. Let's see, the animation, if I remember, this is 6 and 3, right? Okay, there's our slime sprite. I'm gonna just drag this up a pixel or two from the bottom. We want to add our collision shape. I'm going to go ahead and actually open my other slime, and I'm going to copy that one. Where's my enemies folder? Slime. Yeah, this collision shape here. Okay. Why don't I see that collision shape? Oh, its visibility is off. Okay, there we go. So there's our slime collision shape. Just going to help him get around. And of course, let's make sure our slime is set up properly with his collision layers. Where are we at here? So he doesn't need to be on a layer, just like our previous one, but we'll have a mask and check layers 1 and 2. Okay. Basic slime setup. Now, of course, our slime is going to have a few things that we've had before, like our... Actually, let's go ahead and copy them. So if you didn't do this before, let's go ahead and copy the damage area, hazard area, and our edge detector. I'm not going to copy the animation player because I'm not sure what's going to happen there. I might just need to recreate that real quick. Okay, so we've got those. Okay, hazard area, damage area. Okay, now our edge detector script, we'll come back to that, but that's set up to be working. And let's just go ahead and add the animation player. And I'm going to go ahead and recreate the animations like super quick, and then I'll just show them to you at the end. Okay, I've got animations set up. So this is the death animation from frames 6 to 11. I've got a stun animation from 12 to 16. I'm going to make this 0.5 seconds in duration. I guess that death animation was 0.6. And my walk is also 0.6. All of these have a 0.1 frame time, so that's like 10 frames per second. And here's the walk animation, which is looping. Okay, so you should be able to get all that set up pretty easily at this point on your own if you're following along. And now we've got the basic building blocks that we're going to begin with for our slime enemy. Okay, now looking at this script, there's some things I want to do, but really before I get in here, I want to build the scaffolding that represents all of those nodes that we had in our chalkboard, Blackboard I was showing, right? So we've got our enemy script now. It obviously doesn't do anything. We need a state machine script. We need enemy states, a Blackboard script, and a DecisionEngine script, okay? So let's go into our enemy script folder and let's start creating those. So I'm going to create a new script. Let's start with that Blackboard script. And let's see, class name. Now this script is going to extend a resource, which is funny. I used resources pretty extensively in my action RPG series. In this series, we haven't really, but a resource, you can think of it as a data container. Okay, so that's what we're going to use it for here. Okay, next, we're going to create another new script in here for the DecisionEngine. So let's create new script, DecisionEngine. Okay, give it a class name. Now this script can just extend node. That's fine. I do have an icon for this. The resource, we're never going to drop that into the scene tree, that Blackboard. So I didn't bother with an icon there. DecisionEngine icon. Where is it? It's like a gear looking thing. Did I miss it? Okay, I missed that one. In fact, I even had to add it to the zip file. Poor little guy got lost. Okay, here we go. Drag him in here. Nope, just drag it in. Okay, so DecisionEngine, this script is going to extend node, and we're just going to clear this stuff out because we're going to come back to these. Again, I just want these scripts in existence so that I can reference them in my other scripts without it breaking, and then we can add functionality onto them as we go. So next, after the DecisionEngine, let's see, Blackboard DecisionEngine, I think that probably brings us to the state machine. Okay, enemy, create a new script. We'll call it, I'm going to call it EnemyStateMachine. Okay. And this too can extend a node, and we'll give it an icon. And we do have a little state machine icon in here. Okay, where's this guy at? Here we go, little state machine icon. Okay. Booyah, EnemyStateMachine. And then let's create an EnemyState script. Now, how the EnemyState script works is we don't ever use it directly, but we use it as a template to build other scripts. Where am I at? Where's my folder? Enemy scripts, create new script. EnemyState. Extends node is fine, and this also has an icon. Let's see. Where's our little state icon? We use this back with our player somewhere. Oh yeah, this is kind of a weird organizational thing. I guess I stuck this originally when we built this down here in my state folder. I should move this. Let's right click and let's see, move or duplicate to general icons, move. Okay, so hopefully that works. Should keep everything good. Okay, now I got to find that again. Now that I've moved it. What's it called? State. Okay, there we go. There's our little state machine script, or our state script. And voila, we just built a bunch of empty scripts. Congratulations, you are a programmer now. Okay, so we've got our enemy. Let's open this generic enemy script. Okay, make sure you're on the right one. I actually recorded half of this section on the wrong script. A couple things that we want to consider. First, we want signals and export variables, right? Signals so that other nodes can respond to this if needed, and export variables so that we can use them, you know, as a developer. So the signals that we need are these three. At least these are the ones I've started with. Now, keep in mind, sometimes, in fact, I only started with the direction changed signal, and then as I built it, I realized that my enemy should contain these other ones. So was hit. When we're attacked and we take damage, we're going to emit the was hit signal, which will include a reference to the attack area in case we need it, and then a signal when we're killed. Pretty straightforward. Now, if you think of other signals that you want or need, you're welcome to add them. I'm also going to include some export variables. Now, these are essential variables that we'll need. You can think of health like our max health, because we're never going to probably be editing this during gameplay. We're going to use the Blackboard for his current health. Affected by gravity, I haven't actually tested this, but aside from making my slime float, but I'm thinking for enemies that shouldn't have gravity, we can turn this to false. And then face left on start, right? That's an important one, so that when you're placing enemies into a level, if you need them to be facing left, you just check it. And of course, a sound effect for when we die. We don't need one for when we're hit because we've already got a damage area that plays that sound effect. Okay, so there we go. These are the basic export variables that we're going to use. Now, I'm going to go ahead down here and add some variables that I might normally use or implement some of these as on-ready variables, but let me talk about this. Okay, so we've got a sprite 2D animation for animation player, damage area, and hazard area. Because we don't know the enemy that we're attaching this to, there is a possibility that we might not have these. And so that's why I'm doing something a little bit different. And this might be weird, and people can call me out if it is. I'd love to hear your thoughts, and maybe there's a better way. Maybe the export variables for some of these would be appropriate, actually, so that you could assign them. Likewise, I'm going to have a state machine, DecisionEngine, and Blackboard variable. We're not going to assign them on ready because I want to be dynamic in how we grab them. And even if we don't, then maybe we throw some sort of error or something like that. Okay, so there are all of the basic script setup that we need for this guy or for this script. And you're going to find that this enemy script is mostly variables, making sure that we have everything set up and configuring them. And then just a few basic things like physics process so that we can handle our move and slide on this guy. Okay, let's get into some of the functions that we need. We're always going to need an on-ready function for something like this, right? A complex script. So let's build our ready function. I say on-ready. I don't know if that came from Unity. I'm not sure where I got that one from. Because this is a tool script, I'm going to add an engine. So if engine is in editor, hint check. Okay, so we don't need to run most of this stuff unless we're actually playing the game. And then what we're going to do is we're going to have a setup script so that I can kind of defer some of this stuff to later. Okay, so there's our setup script. The other thing I'm going to do here is if we're in the editor, I want to make sure I disable the physics process. I don't know. I just don't want to accidentally place my favorite kind of false. Okay, there we go. Set physics process false. That means that the physics process won't run. We'll come back to the setup, but let's go ahead and implement the physics process. In fact, let's do this. I'm going to go ahead and go through some of this quickly. So our physics process, as I'm putting here in the comment, will move the enemy and it will call the state machine's physics process, okay? Which, just like our player, right? During our player's process, physics process, unhandled input, we were looking at our current state and handling that stuff there. The player script kind of doubled as a state machine. In this case, we're going to have to call a state machine and tell it to do stuff. But we're going to be making our state machine simpler. We aren't going to have unhandled input for our enemies. And we're only going to be using the physics process instead of both the physics and the regular process, okay? So that's going to simplify how we write this quite a bit. And the only thing that we need to do right now on here is, let me just put this move and slide call in there. I don't know, how did I do that? Okay, move and slide, because obviously that's what we're going to use to move our character body 2D. And we'll come back to this. Let's see, we're going to have a change direction function just like our slime did. I think in our enemy in the root is the best place to handle that because it has knowledge of all of the children nodes. Okay, so we could put this in here and I'm going to go ahead and let's see, paste in some of this code. So we're going to have direction changed. We'll go ahead and emit that signal. And then this is what we did in the slime as well. But if we have a sprite, this is actually a little bit different, right? I'm checking, do we have a sprite? And if so, flip it one way or the other. Okay. Now I'm going to add another little helper function down here. This is for playing animation. The only difference between this and just playing an animation is you can see I do an if, and I'm first checking to make sure we have the animation. Because of the decoupled nature of this enemy, it's very possible that you define an animation in a state like play the run animation, but you never created a run animation in your animation player. And so instead of getting an error, this would just handle this. So if you wanted to output something, you could add an else statement, and then you could like do a warning debug. And I can't remember what that's called. Print. Is it like print error? I don't remember. But you could print a message like animation missing. Okay, something like that. And then maybe you'd want to include that animation name so that you knew what was wrong. Oh, okay. It's not print underscore error. It's print error like this. Yeah, let's look at that. Prints one or more arguments to strings in the best way possible to a standard error line. I think that's a good way to handle this. We can't test it right now. Oops, back to script is what I wanted to do. Okay, so we've got a play animation function. We do need to do some handling of taking damage here in our enemy script. If nothing else, we need to emit those signals that we've set up. But really, we're going to connect to our damage area here. I think you could offload this to the decision engine, but for me personally, I don't like that because I'm trying to keep that more logical decision stuff, not systematic decisions or changes. We are going to need to subtract our health, but I'm not going to do that right now. But I am going to say like was hit underscore emit, not underscore, dot emit. Okay, and then we just include our attack area there. We're going to come back. We're going to have other things like was killed and stuff like that. Okay, now the last one, I'm going to copy and paste this in and talk about it, but this is the last function that we need in our enemy. Obviously, some of those other functions need fleshed out. Get configuration warnings. Okay, so we're going to make a collection of warnings, and here's what we're going to do. We're going to go through, and if we don't have an animation player, then we're going to push a warning that we require an animation player. Same for sprite 2D, damage area, hazard area, state machine, and decision engine. So once I save this, you're going to see I've got a warning, and it's because I'm missing a couple of those. I do have some of these items, right? I've got a sprite, an animation player, damage area, hazard area, yada, yada. Okay. But this is just going to make sure we have those in our scene tree so that as we're building new enemies, we don't forget. Okay. So you get the nice little warning here. Okay, looking pretty good. I know this is kind of weird, the approach that I'm going through here, but I'm trying to streamline this one a bit because it's chunky, and I feel like at this point you guys are ready to handle information dump like this. So you can go through your file, make sure it's got the variables, make sure you get each function that I've talked about. Just pause and update the script as needed. Okay, I think now is a good time to move on to our Blackboard. We're going to come back to our enemy script, but let's talk about this Blackboard script because as I mentioned before, this is the script that is going to use to contain the data about our enemy. And it's the script that our decision engine will look at, and then our things like our sensors and our enemy, they're going to update values here in this Blackboard, and maybe even the states sometimes. But anything that changes something about data on this enemy is going to push it to this one file. That way we don't get data, just strewn about. And they should hopefully clean it up. So I'm going to go ahead and paste in here the variables we need. Health. Remember how we said on our enemy, we're going to treat that kind of as the max health? Well, this is going to be the current health. Target is the player, and it's either going to be null or pointing to the player. We're going to use this to determine if the enemy sees the player or not. Okay, so like when our vision sensor senses the player, he'll assign him to this value. And then when the player leaves the detection area of the enemy, we can reset this back to null. And that's going to tell our decision engine whether or not we see the player. Likewise, we've got a distance to target. We're actually going to calculate this within this resource script, but this is just going to tell us how far we are. And we'll be able to use that for things like determining if we can attack or something like that. We've got a little Boolean in here called can decide. So we're going to be able to set this to false in some of our states to tell the decision engine to, hey, stop trying to make a decision a bit, because right now I just need to let the state play out. An obvious example of this is going to be the stun state, right? The enemy's not going to be making decisions during that brief period where he's stunned. So we would set this to false when we enter the stun state. And then when we're ready to exit it, we can set it back to true. And then the decision engine will kick in and take over. Edge detected, I think that's self-explanatory. Do we see an edge? Damage source. Whenever we take damage, we want to keep a reference to the damage source here in the Blackboard. That way, all of our other scripts can access it if needed. And lastly, a direction that our enemy is facing will be stored here. You notice previously in our enemy, like in our slime script that we originally built, he had a direction right here. Okay, but on this new enemy script, we do not have a direction, right? Because we've offloaded that to the Blackboard. And there we go. Those are the basic variables. What's cool about this is extendable. You can add your own unique variables as needed. You know, if you determine that you need to add some other type of thing here to track, you know, then you can. And then that just becomes available. It will become available to our state machine and all of our states very easily. So the last thing I want to do is I want to just put in this update distance to target. This is a really simple function. And you can see it's going to require us to pass in a position, a vector 2. And it's going to say, okay, if we've got a target, then let's calculate it. And what we're going to use, this position is going to need to be probably the enemy's global position, right? So we'll pass that in, and then it's basically going to go from the enemy, what's the distance to the player? And if not, we'll set it to -1. So this is another way you could determine distance, or if you see the player. If it's -1, that means you must not have a target, right? So there we go. That's the Blackboard script. Pretty simple, right? I hope this one makes sense. Kind of weird, kind of abstract. As we start to integrate it, though, I think you're going to see the reason why we have it. Okay, I want to move next to our enemy state. This is just a boilerplate, simple script, okay? And this one's going to be super lightweight. And I'm using some shorthand here. Okay, so what do we got? We have an export variable. Each state will have an animation name that you can optionally assign. I'm going to show you how we'll use that. It's not necessarily required, but I think it'll make it easy. Our states also need to be aware of the state machine, the enemy, in case they need to do things like set the velocity on the enemy, as well as the Blackboard, because they might need some of that information on the Blackboard to be able to make determination or things like that. You know, they'll need access to the direction or maybe the hit points or whatever it may be, target. Okay, so there's going to be 4 functions that we can use on our state. We've got an enter function and an exit function, which you'll recognize from our player state machine. And likewise, you'll recognize we have a physics process. Note that this does not have the underscore because we're not using the built-in physics process for this. This is in fact, it's not even called physics process, it's physics update, right? But I'm still passing in the delta, and we're going to call this every physics tick on the current state. And then there's one additional or new type of function, which is re-enter. So because I ran into some issues with the decision engine and how to handle when you do something like a repeated state back-to-back, but you need it to do something, most states will do nothing on re-enter. Like if you're walking and the decision says keep walking, it will do nothing. But if you're stunned and you get stunned again, that was a situation I ran into. Well, then what we need is we need a re-enter for the stun state. So the stun state's going to implement this, and other states in the future might. But this is just, right, the boilerplate template for what an enemy state requires. And of course, we'll be creating new states that will override these functions and what they do later on. You might think we're going to go to the state machine next, but I want to jump to the decision engine. You'll notice we haven't really referenced the decision engine anywhere except in the enemy state or script. So let's see, decision engine right here. This mysterious script, this is the one that we're going to override in the future, but for now we're going to build just the boilerplate again. And once again, though, this is a very simple script. We've got a reference to our enemy, our current state, and our Blackboard. Okay, we need this information, obviously, to help us make decisions. And in our ready function, what I'm going to do is I'm just going to wait until we get an enemy. So while there's not an enemy, wait, and you'll see we're going to assign the enemy from the enemy script. So this is just going to, usually this will only wait one process frame and then it'll work. And then what we can do is set up one thing. Now we could have called this from the enemy, but because we're removing certain decisions, I thought it would be fun to just put the change direction in the decision engine ready function. Okay, so we've got decide function. It will return an enemy state. So this is kind of like how in our player state machine, our different things like physics and update could return a new player state, which meant, hey, you need to go to this state next. That's what the decide is going to do. And it will by default right now return null, and you can return null. We'll support that in our code, but most of the time it's probably going to be returning an enemy state that the decision engine thinks you should be in. Because the one thing that the decision engine won't know very well is what states you've been in recently. It only really knows what state you're currently in, and it knows what's in the Blackboard. Okay, there we go. Decision engine, one more script done. Okay, now that we've scaffolded out most of these scripts, we need to go to the enemy state machine next. I think this is the last of these guys that's outstanding. Okay, you know what's interesting, just real quick, another comment, DecisionEngine will be overwritten. Obviously, this doesn't do much. I'm saying this is complete. This is a template. Same with EnemyState. This is a template, okay? Our Blackboard is a data container. The state machine, we can finish the code on this right now. Okay, much like our other scripts, we're going to have a few references. So we've got our enemy, the Blackboard. We're going to have a collection or an array of enemy states. And then, I don't know what's going on with my copy paste today. There we go. It's really me. I'm just selecting weird. Okay. And then we've got a current state and a previous state. This is going to be a lot like we used in our player. You know, he had this function where we return the front state or state at position 1. And we'll use these maybe to determine stuff, right? The current state we're going to use for sure. Previous state, not 100% sure we'll really use it. In fact, for most intents and purposes, we might not need previous state, but it's there in case you do need it, right? In which case you could, I don't know how you'd handle that, but you'd still want an array of states so that you could maybe keep track of them. But I'm just getting way ahead of myself though. A couple things that we need to do. Now this script should set itself up, but we're not going to use the ready function for this. Maybe we could, kind of like how in our decision engine, we've got ready that we're waiting for it to have a valid enemy. I think that's an okay approach, but I'm going to do a different method here. We're going to create a function that we call setup. And what we want to do is the setup is going to need reference to the enemy and the Blackboard so we can populate those. Okay. Technically, the Blackboard is going to be a property on our enemy, so we might not need to pass it in, but it makes it obvious what's happening here. So then what we can do is, assuming we've passed these in, we can now configure and set them up. So we can say our Blackboard is equal to B, right? And then I guess we could say enemy equals E, like so. Now, the other thing we need to do is we're going to have a bunch of states. And we need to set up our states, because if you remember our states, let's look at enemy state. They also have state machine, enemy, Blackboard. Okay. So I'm going to go for C in get children, because we're going to have a state machine in our folder here, and then there will be states as children of it. So for each child, if it's enemy state, then we go C.enemy equals E. C.Blackboard equals B. Let's see, it also has a reference to the state machine, so that can equal self. And then we'll just add this to our states list, so states.append C. Okay, so now we're going to have that in our array. And then once we're done with all of this stuff, then we'll just enter our first state. So we're going to go states.front, or I guess we could get current state, huh? Current state dot, and then we're going to have an enter called on that state. Okay. So just like that. Pretty cool, right? Pretty easy setup. So this means that whatever state you put on the top of your scene tree is going to be the default state for your enemy. I guess that's important knowledge. We'll have to try and remember that when we get to setting it up. Now, next we need a change state function. Okay. Now, obviously, when we call this, we're probably going to expect us to pass in the new state that we're changing to. And I'm going to copy and paste this code real quick. Okay, so here's the code. If there's not a new state, meaning it's null, then we'll return. If the new state equals the current state, we'll call the re-enter function, right? Which in many cases will do nothing, and then we'll return. So we're not going to call exit, we're going to call re-enter. Now, if neither of those happen, then we know that this is a new state. So we'll exit the current state. This check is just because, first time around, we might not have a current state. So we can exit that. Then we're going to push the new state into the front of our array, so it becomes the new current state. Then we will enter that, because just to refresh how this works, current state returns the item at the front. So when we push one to the front, then current state will return whatever that item is, okay? And then we just check if there's an enemy, then we want to set the decision engine. We want to say, hey, set the current state on the decision engine to this new state. And I'm going to resize my array so we just keep a history of two, the current and the previous state. Okay, so that's what the change state does. This is somewhat similar to our player's change state function. It's a little bit different, right? Like the introduction of the re-enter state. So this condition is split out. It was combined with a null check up here and some other things, like we didn't have this concept of a decision engine, so we didn't need that, but basically the same thing. And then lastly, we need our physics process. You know what? Let's change this name. Let's call it physics update so that it's named similarly to our state and that it's not too easily confused with the physics process in the engine. Okay, so physics update, we provide a delta. If we've got a state, call that state's physics update. Okay, that's all we're doing there. And that is our EnemyStateMachine. Talk about minimal script here. Okay, so there we go. We've built out quite a bit of stuff. We do need to revisit our enemy script so that we can start bringing this all together. And then, of course, once we get them all tied together, we need to start branching out, right? We need to build a decision engine that works. We need to build enemy states that work, and we need to start adding them into our scene tree. So let's wrap up the enemy script, and then we'll be ready to start expanding and making something happen. Sorry that nothing's happened yet in the video. Maybe a little bit boring. I don't know if you guys can bear with this, but this is just what this is what I came up with. So heaven help us. Here we go. Back to the enemy script. We've already visited and revisited this script, so maybe this will be the last time. We left the setup unfinished for one, so let's work on the setup. What we're going to do, we've got these variables that we need to handle. Okay, so we're going to handle that in the setup. First thing is let's address the Blackboard, because we're not going to drop the Blackboard in. Remember, the Blackboard is a resource. We could have it as an export variable, but really, because it doesn't matter where it comes from and we don't need to pre-configure anything on the Blackboard, what we're going to do is we're going to say Blackboard equals, and then we can type Blackboard with the capital B, so it's the class name .new. Okay, that's going to create a new instance of that resource. So there we go. We've now got a Blackboard. And in addition to that, we've got hit points or health here and in our Blackboard. We need to update our Blackboard's health to be whatever it is. So Blackboard.health, it needs to be whatever our health is here on the enemy. Jeez Louise, Mike. Can't you type, you dork? Okay, health equals health. There we go. Blackboard health. Boom. Okay, that's it for the Blackboard, really, I think. We'll be referencing this later, but that's all we need to do to set it up. Create a new one, assign the health. Okay, now we're going to go over the children. I don't know if people use get children as much as I do, but as a father myself, I sure love the children's. Yes, okay. Get children. So here what we're going to do is we're going to iterate over the child nodes, and we're going to look for each of these, assuming that we've added them to the tree. Now, what's nice about this approach is we don't have to drag them and assign them in an export variable, and we don't even have to worry so much about the name, okay? We just have to make sure that they're present, and our little configuration warning will let us know if they're not. Now, that downside is it's a little bit less obvious that they're missing. You have the configuration warning. Other than that, I don't know. So you guys can tell me if you like this one or not, but we'll just check. So first child, if C is an animation player, then we know that we can assign this to our animation variable. Okay? No, not change dir, C. Then we'll do an elif. So L if C is sprite 2D. That's our sprite. So we can assign our sprite to that child. This does mean that you probably only have one sprite, one animation player, so on. You may need to modify your code if that's not the case. However, any additional sprites or animation players you need, you could have nested under other nodes. And then this code will be fine, because this is only going to check the children at the root level, one level deep in our scene tree. Okay, so the next check is let's see, animation player sprite. Let's do damage area. We can assign our damage area. And if it's a damage area, we do also need to connect to that signal. So let's go to C dot, and then what's the signal called? Damage taken. I don't know why that's not showing me. Dot connect And then we've got an on damage taken function, just like that. Now, actually, you know what? As I'm going through this, I'm realizing that we might want to make this safe. If you want to check, and I do, I'm deciding I want to do this. If you want to check to make sure that you don't already have an animation player stored, you can add this. So here it would be and not sprite. So if sprite's null, oh, that should be animation. Okay, so if you find an animation player and animation is null, if you find a sprite and sprite is null, right, and not damage area, so on and so forth. Okay, let's repeat that going forward. What else do we have? Next, we could do our hazard area and not hazard area. Then hazard area equals C. Okay. elif, no colon yet. Let's get our state machine. So enemy state machine. We should never have multiple state machines. We should always just add one, but just in case, this is the one we will use. After this, we have our decision engine. Whew. Okay, there we go. Okay, this is future me coming in to fix an error that I didn't catch during normal recording. This line 44, my damage area check here, needs to say elif C is damage area, right? I left that off. Okay, there we go. Back to the video. So this is going to help us go through and collect all of the required nodes and assign them to their variables so that they're easy to access. And then lastly, I'm going to do a check because there's if we don't have a state machine and a decision engine, then this isn't going to work, right? And one thing that we've done is like up here, we set our physics process to false. If we don't have these, I'm going to do that as well. But if we do, then we need to do a little bit extra configuration. So we're going to say if state machine and what is it? Decision engine. Is that the other one I said? So if we've got both of those, then what we'll do is we'll call our state machine setup function that we just built. And remember that state machine setup function, it requires an enemy and a Blackboard. So self is the enemy and Blackboard is the Blackboard. Okay. Then we can call our decision engine and let's see, enemy equals self. See, we could have had a setup on our decision engine, I guess. And the decision engine dot Blackboard equals Blackboard. Okay, there we go. So now we've set up and we're ready to go. If that is false, then I'm going to set our physics process to false, which means that it's just not going to run, right? It's not going to run our physics process, and that's not going to work. Okay. Let's go ahead and do the physics process next. We did start it, but we didn't finish it. It's going to be pretty straightforward. So kind of like our player, let's look at a reference of how our player worked actually just for fun. He's got a process. We do this change state, right? On our process, our physics process. We do stuff like that. We're going to do something similar in our enemy. So what we're going to do is we'll call state machine dot change state. But what we'll pass in is a decision engine dot decide. Okay, so every physics tick, we're going to have our physics engine try and make a decision. And if it returns a new state, see, it returns an enemy state, then our state machine will change to that state. If it's the same state, remember, we built it so that it will call the re-enter function on that state. But that's how our state machine ties into our player. Very simple and very straightforward. We do need to do a state machine dot physics update and pass in the delta. Okay. And that's pretty much it. But we have one other thing that we're going to do. We are going to handle our gravity here. We'll set the X velocity from our states, but we do need to update our Y velocity at all times, unless we've maybe flagged not to, or maybe we add an override for that. But I'm going to say if affected by gravity, remember that Boolean we added? Then we're just going to do, let's see, velocity plus equals get gravity multiply it by the delta. Okay. We're going to apply our gravity before we do this. I don't know if the order is super important, but I think that'll be nice. I think that's a good way to do it. Okay, so there we go. That's our physics process for our enemy. Once again, pretty straightforward. You guys are probably like, yeah, but does it do anything, Mike? Gosh. Oh. And the answer is, I don't know. I think so. It did when I tried it, I swear. Okay, let's see. Change direction. Looking pretty good. Let's do one other thing here. We just need to go back through and kind of integrate these new systems into our enemy, right? So one other thing that's changed is we now keep the direction in our Blackboard, not on the player, right? So you notice we never set the direction here. We just did our sprite flipping and emitted this signal. So we'll do blackboard.dir equals new direction, okay? Pretty easy, makes sense, right? So now that if anybody's looking at the Blackboard, they'll be able to get the direction from the Blackboard, okay? Where was that? That was change dir. Okay. Play animation is good. On damage taken. This one too. So the health, because our health is on the Blackboard, we're going to say blackboard.health minus equals a.damage. And there we go. Okay. We do want to do some other things though, because we want to check to see if the enemy is dead. So we'll do a check for that here. So we'll say if blackboard.health is less than or equal to 0, then we know the enemy is dead. So I'm going to do the same things we did in our slime. I'm going to take our damage area and Q free it so that we can no longer damage him. And I'm going to take the hazard area and Q free it so that we can no longer walk into him and be hurt while he's playing his death animation. And then I want to emit the was killed signal. Now, this is worth pointing out that we are still emitting the was hit signal. So we'll emit 2 signals when he dies. And because we've destroyed the damage area, this on damage taken will never get called again, right? Because the player can't hit him anymore. So once he emits both of these together, that'll be the last time he emits those signals. There we go. On damage taken is now complete. And you know what? I think that means all of our scripts are complete. At least all of these ones. Ooh, I bet that feels pretty good. Okay, we've got our enemy. We still need to add some nodes. Like if we look at our configuration warning, we've written all the code for these various parts to work, but we haven't added a state machine or a decision engine. So let's add that real quick. I'm going to add a state machine, at least a state machine. Okay, so that cleared up. We only have one warning left that we need a decision engine node. Okay, but this is where I'm going to drop for now. And I want you guys to see if you can figure out a little bit of how this works. But I'm going to have a real quick follow-up to this. Because this video is getting long, I'm going to break it into 2 parts. This is a benefit to me for one particular reason. And that's because I have this auto-translate feature in YouTube that I've experimented with in the past and struggled with as well in the past. If I had videos longer than 1 hour, the translator will not try and translate them. And it's not significant necessarily as far as views go, but I do have a growing fan base that speaks Spanish, German, whatever, Japanese, Chinese. And so I'm going to try and provide it for them. So I'm going to cut it here and I'm going to move on. The next few steps are going to be implementing a decision engine, because clearly we didn't really finish that today, as well as building some basic enemy states. And what we'll do is we'll start with the states and the decision engine that we need to make our slime work, okay? And that's going to get us prepped so that we know we can make a working enemy with this system. And then from there, once we look at the enemies in the design showcase, we're going to bring some of those in and we're going to build the pieces, whether that be states or new decision engines, so that we can make these other cool enemies work. So thank you for following along. I know this video was kind of boring, but if you've stuck with me this far, it's probably not a big deal to you because you're used to the fact that I'm covering things in detail. And we're going to just step through this and make sure that this thing works. And next video should be a lot more fun because things will actually start happening as we implement. So yeah, go ahead and stick around for that. Hit subscribe if you're new so that you can see what's coming next. and be on the lookout. I mentioned the Enemy Design Showcase. I don't know when exactly that's coming, but it's coming very soon. I've got a lot of great submissions, so I'm really appreciative of those who've put themselves out there to do that. It's going to be a lot of fun. I'm actually, more so than just showing them, I'm excited to put some of them in the game, because some of these enemies are not ideas I think I would have come up with on my own, which I think is the beauty of doing this community-based design for this chapter. So yeah, thanks for participating. It's going to be awesome. And of course, thanks again for watching, and as always, we'll see you next time.